Good evening, everybody. This is going to be an introduction to classes and a discussion of the anatomy of a class. Now, a class in Java is basically, as you can see here, we are making class files. Java class is basically a template. And to start out, it's a good idea to talk about what a template should be for. Well, a template represents either an object in the real world or a concept or something that has some variation but has some basic attributes that you can set down and then later change. Um, so a classic example that we work with in class is the circle object. But right now we're going to look at first a box object or box class and then a book class and to see how they differ, see how they're similar, and what's involved in making both. So to start out, we're going to make a box. Let's call it rectangle. And there is a rectangle class already extant in Java AWT, but this is going to be our own creation. So to start out, let's comment the top with a java.comment /* and then enter will create your java.comment. And set your name. You can write a purpose if you want. Okay. And we can say generic rectangles, various rectangles, whatever we want. But it's going to be a template that should be able to represent any rectangle. It should be able to hold all the information that we care about. So classes typically have fields, methods, and constructors. Fields are basically what we've been working with. Variables hold data. So they hold data, but there's some differences between normal variables and the instance variables we'll be using, or class variables in the future, because of how they end up being used. Methods are, in any other language, functions or actions performed by or to the class. We could say the class or instance thereof. And that we'll get to a little later as well. And constructors are basically the builders of the class. So describe special methods that describe how to build a class. Okay, and what I mean by that, well, we'll talk about constructors in a moment, but in essence, these three things are typically present in any class that we're going to deal with. And they're not necessarily set to any values, but they're things that become useful if we decide to create a rectangle to use in a specific situation, or something that represents a rectangle. So to start out, I am going to make a field. Now fields, again, are just variables, so they need to have a type and they need to have a name, an identifier. So fields, so the field, again, should be standard to have a type and an identifier. Those are necessary. Additionally, for the purposes of our work currently, we're only going to be dealing with instance variables, and we're going to be dealing with them as they are private. And the reason is we only want to make use of them in this class and not have access to them outside of this file. or this class file, this class definition. So we're going to say here, I'm going to make, well, let's see what we care about with rectangles. We care about perhaps a width and a length. And I think that's pretty much all we're going to worry about for now. And those are going to be our fields. So I'm going to say private width. But what am I missing? The type. What type are we thinking of? We're thinking of, we could think of an int. We could think of a double. Let's go with double. So we can have decimals for our width. Make this a slightly more advanced class. Private double length. And you notice how I'm not initializing them to anything. Generally, we're going to leave that job to the constructor. And the constructor, again, is just a special method that defines, in a lot of cases, our defaults. It generally has to be there, and it'll define our default behavior. So let's talk about how we are going to define that. Well, the constructor is generally going to be public, and we can just call it rectangle. And that, rectangle, okay, perfect. And that is our constructor. And generally you can think of a constructor as an all-purpose person who, you can think of it as like a construction worker who actually does the building based off of our blueprint. If the class is a blueprint, the constructor is the person who reads the blueprint and decides to implement it. Now, obviously, not all rectangles are going to be the same. I could give these variables initial values in here. So I will give these initial values. I'll initialize them in here. Width equals 5.0. And maybe I'll make a note here that this should be in meters. And this should also be meters. Because metric system is boss. So now let's initialize our length. Let's say we'll have a square here. A 5 width, 5 length rectangle. Now, what this does is every time I decide to make a new rectangle, or to use this blueprint to build a rectangle, that's what we're building this for, to build rectangles for use later, it's going to pop into existence with a width of 5 and a length of 5. We'll decide to change this in short order, but for now that's fine. We can think of a constructor as something that just sets defaults. So we're setting our default values, and that's all well and good. Finally, we have to talk about methods. And we haven't gone into detail about the anatomy of a method, but needless to say, they end up being useful as we talk about them all the time, and we've used a number of them up to this point. And what methods are we going to care about? Well, what information should we know about a rectangle? Well, there are a couple pieces of information that we might consider useful. We might consider the area a useful method to know, or a useful piece of information to know, and we might consider the perimeter a useful bit of information to know. And as we like to name things in a useful way, we're going to name our method getArea, and we'll name our other method getPerimeter. So the way we're going to do this is we're going to use this keyword public. It means that we can use it outside of this class itself, outside of the file. We're going to say that we are going to want to get some information from this method, and that information is going to be in the form of a double. And then we're going to give it the name. Put parentheses next to it, braces, and you are set, except we have an error because we have to return a result of type double. And what that means is that because we said we're going to be presenting some information to the user here, we need to actually present that information. Right now there's nothing there and it's complaining because we've made a promise and we're not making good on that promise. So we have to go in, pinky swear again, and give back some information. To give back some information in a method, typically we're going to say that we are going to return that information to the user, or through the method we're going to return information. And in this case we have to return a double. And how do we get area? Well, the area of a rectangle is the length times the width, or the width times the length. And it's a simple bit of math, but it's a good demonstration here. This is sufficient for a method body. In fact, you could have nothing there if you have no return type. It's called the return type. But in general, what we're looking at here for a method is we're going to say public, for now, return type, if any, and then name. And this return type can be any data type whatsoever, an object data type like string, or a primitive data type like double, or it could be void. And void means we are not giving information back. And there are some cases where you definitely want void methods, and we'll talk about those in a future video. Now, to move on from this, I'm going to say that we are going to make another method using the same schema, public, double, get perimeter, and I just want to emphasize that the computer has no idea what get perimeter means. It has no idea what get area means. It's just a name that we're attaching. The reason we're using something so descriptive is because it helps us know what's going on. We are the ones who are using this program. So if we look at this in a year and we see a method named XYZ, or the tombstone of Genghis Khan, it's probably not going to give us the information we want to tell us what our program does. So here's another method, get perimeter. Well, we have to return information. And we're going to return the width, 2 times width, plus 2 times length. And that is, as far as I remember, the way to find perimeter for any rectangle. So I think right now we've given a relatively good description of a rectangle. It has a length and a width. And if we wanted, we built something that can calculate its own area and get its own perimeter. And that is information that the user then, for any rectangle in the future, can use and can play with. Now, we're going to look at using this class in the next video. Till then, good night.